Hey everyone, a very warm welcome back to the channel. Today we have the question number 8 from the chapter of maximum minima from applications of derivatives. The question reads, the lower corner of a leaf in a book. So basically leaf is nothing but a page only. So don't get confused. It's just a page in a book is folded over so as to just reach the inner edge of the page. The fraction of width folded over, if the area of the folded part is minimum, would be equal to how much? And then four options are given. So the maximum time allotted for this question would be 10 minutes. Ideally, you should try to do it within 3 minutes, and you can pause the video, give the question a try, but then make sure to return back to have a look at the correct solution. So I hope you all have tried it out. Now the answer to this question would be option number B, which is basically 2 by 3. Now the concepts and formula used are very basic. We should know the method of finding global extrema, in which we check the endpoints, then derivative equal to 0, the critical points. So all those things we should know, and tan theta is equal to 1 minus cos 2 theta upon sin 2 theta, a very common formula in trigonometry also we should be aware of. Now let's see how to actually solve the question. So basically we are assuming that there is a page ABCD, and we are folding the page along the crease EF, we can say. So we have folded it along EF, and after folding it, this point C lands at the point C dash. Okay, so that's how we have folded it. And one more thing that we have done here is that CD we have assumed to be equal to 1 unit. The reason is that since there are no side lengths given, we are free to assume anything as anything, right? Because at the end of the day, we have to find the ratio. So what we can do is we can forcefully say or assume that CD is equal to 1 unit. There is absolutely no harm in doing that, and is absolutely correct. So that's pretty much what we have done. CD we have assumed as 1 unit. We have defined it to be 1 unit. Now easily we know that ECF triangle and EC dash F triangles will be congruent because they are simply the same paper, right? I have just folded this portion ECF, and after folding it comes out to be this triangle, right? So obviously they are going to be congruent, and this length I have assumed x, so the remaining length would be 1 minus x. And if this is theta, then of course we can say that both of these angles will be theta. So the reason is that they're congruent, right? So, and this would be 1 minus x into tan theta using simple trigonometry. So the point here is that these two are congruent triangles, so their areas will also be equal, and CF would be equal to C dash F equal to 1 minus x, right? So basically, and one more thing, C dash FD angle obviously would be equal to pi minus 2 theta, because this entire angle is 2 theta, right? So the remaining angle, this blue angle, is pi minus 2 theta. Now we can say that DF would be equal to C dash F cos of this angle pi minus 2 theta. Very basic trigonometry. So now we will just substitute in the values. So this is actually equal to 1 minus x. This will become minus cos 2 theta. So it becomes, and of course, DF is nothing but x. So that's how we have written this expression, and dividing we get or rearranging and dividing, we get x value equals to this quantity in terms of theta. Now this is what we are calling as equation number 1. Now the area of folded part would obviously be equal to area of triangle ECF, which can be written by half into base into height as this quantity. Now 1 minus, so basically x value we already have in terms of theta, so that's what I substitute here, and the entire expression comes out in terms of theta. Now here what I've done is tan theta I've written as 1 minus cos 2 theta upon sin 2 theta, and on cancellation and using basic manipulations, this is the expression that we get. Okay, because 2 sin a cos a is equal to sin 2a, that formula I have used here. So a of theta is this. Now one thing we should observe is that 2 theta obviously would be more than 90 degree or pi by 2, but less than 180 degree, right? Because if you fold it, it can't go more than 180 degree, right? So but it has to be more than 90 degree, otherwise this will never meet. Only the point C dash will never be able to meet this edge only, right? So it is very obvious that this angle 2 theta would basically lie from pi by 2 to pi. And another thing to look at it and understand is that, okay, this is positive, so this needs to be but this is, coming out to be minus cos 2 theta. So cos 2 theta needs to be negative, so that negative into negative becomes positive. So cos 2 theta being negative also means that 2 theta must be greater than pi by 2. So either way you can deduce this very obvious fact. Now to minimize a of theta, we simply need to maximize the denominator, which we are calling as d theta equal to this quantity, where theta obviously lies from here to here, because 2 theta lies from here to here. So if you divide by 2, theta would lie from pi by 4 to pi by 2. Now at the end points, we'll first calculate d of theta. So d pi by 4, d pi by 2, 2 and 0 they come out to be, and then we differentiate d prime theta and equate that to 0, solving which we are basically getting cos 2 theta is equal to 1 or minus half, but 2 theta is an obtuse angle, so cos 2 theta, it is not possible for it to be positive. So this is rejected and this is accepted, minus half is accepted, and 2 theta then would be equal to 120 degree, because this is obviously cos of 120 degree, right? So theta comes out to be 60 degree or pi by 3. Now d of pi by 3 comes out to be 2 root 3, which is clearly the greatest among these values, 2, 0 and 2 root 3. So obviously this is the greatest, so this will be accepted as the global maximum. So from the equation number 1, what was the equation number 1? It was x in terms of theta. So that comes out to be when theta is equal to 60 degree, x comes out to be this quantity, which is simply 1 by 3. Fraction of width folded obviously would be equal to the amount folded upon total length, which is CF upon CD. CF length was 1 minus x, CD was 1. So the answer comes out to be 2 by 3 as our final correct answer. So quite an amazing problem, where geometry and monotonicity both were involved. And the main thing to notice in this question was that x and theta are two variables, but we need to convert everything into one variable in order to use the things, that the concepts of AOD that we have learned. If we had two variables, it does not become possible as per the syllabus, because we can't use Lagrange's multipliers or anything else, right? So the main feature of this question is that we must be able to convert one variable in terms of the other variable. So I really hope this problem helped you out and gave you a thorough learning experience. Make sure you like the video, comment down below what more you would like to see next, share it with the friends, subscribe to the channel, and I'll see you all in the next one.